All right, let's continue with our thermal simulation workflow and now talk about windows. When we talk about windows, we're talking about sunlight. The sun bombards us with electromagnetic radiation, which we experience in a lot of different ways. It's essentially a spectrum, so it's a ton of different frequencies. Visible light is a very small band of those frequencies, and for example, at a little bit shorter wavelengths next to it is ultraviolet light, which we don't always feel like at the beach, but can burn us. And so the point is that there's this big spectrum of energy hitting us, and one way to look at it very simplistically is that we have a rock we live on. It's surrounded by gas, bombarded by the sun. High energy electromagnetic radiation goes through our atmosphere, is absorbed by the rock, and then re-radiated at different wavelengths, longer wavelengths, that then the atmosphere stops a lot of those. So the same energy that's coming through the atmosphere is then blocked by it, and this allows us to create different temperatures, or, well, not us, the planet. There's different temperatures near the surface of the planet than there are out in space. And we can take advantage of this same reality in the design of glazing, because what we're saying here is that the wavelengths for visible light are very different than the wavelengths frequencies for heat. And so we can design glazing units, often, to code always more than one pane of glass at a time in a package, that allow different percentages of light and heat through them. And so based on where we are on the planet or what side of the building we are using the glass, we can tune it to have the characteristics we want. And this is a whole world of design. We don't want to get into the details of it, but we need to understand the basics so that you can understand the settings that you're going to choose in Climate Studio. This on the left is a label from an Energy Star certified window. We have U factor, solar heat gain coefficient, visible transmittance, air leakage, and condensation resistance. The things we would deal with in Climate Studio or in our thermal analysis at this level would be U factor, which we already know is the amount of energy that it passes through the unit, and R value is the reciprocal of that. Solar heat gain coefficient is just the percentage of solar energy that will pass through the glass that will be experienced as heat. So for example, this label is talking about a glazing unit that has 32% of the heat that is that is incident to the outside of the glass will make it through to the inside of the building. And on the other hand, 51% of the visible light will pass through, and then there's a certain air leakage percent or rating that we won't talk about right now. So that's the basic idea. And finally, all we need to realize is that windows are pretty complicated. They can be, so on the left there's a wood frame, on the right this is an aluminum frame window, could be steel. And there's in contemporary glazing units, there's 2 or 3 panes of glass, could be more. The central plane could just be a low E coating, it could be a piece of plastic. That's part of this strategy that we're talking about to let in the kind of energy that we want to let in the situation we're in on a certain facing of the building. The only point here that I'm making is that if we go look in a second in Climate Studio, we'll see that right now we're not even turning on the frame. So we're just saying we're designing a glazing unit that's all glass. So let's look at Climate Studio and delve into the settings here. So far we just picked default glass in the runs we've done thus far. So what does that mean? This default glazing has I'm going to change to IP units from SI. It has a U value of 1, which means it has an R value of 1. That's pretty bad, right? If we have a wall, let's just say typical wall might be R11, could be a lot more, could be less, but so this is a tenth of what we would expect in a wall. So glazing often has a poor resistance to heat flow. This single pane glass has 90% of the heat is passing through it, and also 90% of the visible light. This will become much more important when we're talking about daylighting. But now the point is just that's the glazing that we used in our runs so far, and it's the glazing that produced, for example, these outputs and that we used in our shading. So let's look at some other options and see what effect they have. I'm going to select all my glazing. This is something you can do. So I just hit Control and I'm selecting the glazing. Now if I hit Edit, I'm editing all of that glazing. And I'm going to click on the default glazing or the glazing definition tab there. And I can come, there's a huge number of glazing packages here. These are all actual window packages you can buy. A lot of them have proprietary names. We don't want to create our own. Let's just find examples that we actually could purchase. Let's and the way this input setup works is that we can filter, or we can create a chronological order based on a tab. So I'm going to select U value, and now I see that I have the lowest U values to the highest U values in order. So that's a good way of doing it. What I want to do first, though, is I'm going to type in 90.1, which is a standard it's a code standard we'll talk about later, but it's a good baseline for contemporary building. I'm going to say this is residential. Using this standard, CZ means climate zone, so climate zone 4 would be where we are in New York City, and I'm going to pick fixed glazing because, like we said, we're not actually opening this glass because we don't even have a frame on it in the model we're doing. If I select that, then I can come out to this next window, and here, this is what I was just to point it out. I haven't even turned on the frame, so we could define a frame later if we wanted to, its conductance and how big it is. That has a large effect, but we're just playing around now, right? And also, we're not creating an operable window that we could use in, for example, a natural ventilation strategy that we could also simulate. So this is very simple. These are things we could come back to in, later when we're doing a more complex model. Same thing with the shading here. We're not dealing with that at this point. Okay, so what happens with if we add this glazing? Let's just go ahead and I'm turning off, making sure I don't have any. All I've got now is I've got my slab down here. Right, slab, I've got my zone, and I've got these windows that we were just looking at. And so and no shading. I turned the shading off. I'm going to run the model. And here are our results. I've actually run these already and named them, so I'm going to just kind of go back and forth. So you'll see here I call this 90.1 residential Z4, so that's let me know which glazing package I chose. And if we compare it to the best we could get with our shading with the single pane glass, we see it's a major difference in EUI, energy use intensity, which is a good thing to look at as just a basic summary metric. But then also if we come in and look at our energy flows, we can compare. So with the default glazing with shading, this is our heat gains and losses. Remember that the black line is 0, and we have the months along the x-axis, and then on the y we have gains below 0 and losses below 0 and gains above. So we'd want gains in the winter, and we don't want gains in the summer. That's what we're looking at here. And so if we compare the default with shading to our 90.1 standard, we actually see that well, it seems that we are actually gaining more with the new glazing, but always be careful that what's happening is this the range here is changing. So we're actually reducing our loading quite a bit, or our gains, I'm sorry. And anyway, I don't want to go in, I just want to show us how to do this. And the real way to learn about, a great way to learn about these basic building science concepts is to run these simple models and play with them and try to figure out what's going on and why it's going on. Okay, so that's sort of a decent basic piece of glass. Did we even look at, I don't know if we didn't. That's kind of silly. Let's look at what the settings were here. So the other glass had a U value of 1. This has a U value of 0.36. Remember, if we will want to find the R value, if you're more comfortable with that, we just do the reciprocal. 1 divided by 0.36 equals, so it's getting close to an R value of 3. It's almost 3 times as much as it was as the default. We have a solar heat gain coefficient of 36%, and the same thing for our visual transmittance. We'll see more about, we'll talk a lot about visual transmittance and daylighting in our daylighting analysis. Right now, it's just that, in my experience, if you get this too low, you're not really talking about vision glass. It's very dark and it can be colored. Maybe that's what you want in your design, but just realize that that's another thing. If we're trying to have vision glass, that you have to be conscious of this variable. And this is a really good point in terms of modeling. You make this beautiful architectural design, but then your engineer or you, because of requirements you have for energy efficiency, you choose a glazing package that really destroys your view shed or the vibe of your building because the form is there, but then you had to change the components based on performance. So that's another reason why we're doing this. Okay, so let's try some other glass then. So if I go back out of here and select my windows again, let's try. Let's just dive into this world of different glazing packages. And when I say glazing package, what I'm talking about is 2 or 3 panes of glass together. By the way, that's why if you see over here type, like triple means triple pane, double is double pane, single score single pane. So let's just so what I did is I sorted based on U value. I'm going to pick this first. It's a triple pane, so the triple pane is going to be pretty expensive. It's a U value of 0.1 though, so that's going to be an R value of 10, really pretty good. Solar heat gain coefficient very low of 22% about, but a really good visual transmittance. So this is again like what we were talking about at the beginning of this video. I'm only letting through about 22% of what will become heat inside the building, but I'm letting through 51% of the potential visible light. And that we're doing through scientific design of glazing that we've developed over years of practice. So okay, anyway, let's see what this does to our model. I'm going to run it. And again, so all I did was just change those. I could have done that in 10 seconds if I wasn't talking to you about it. And now we are, this is our results, but I have got it named here. We are at, and this is the way I decided to do this. I called it, T would be for thermal, I, so I'm going A, B, C, D, E, F, G, H, I. It's important that you name these. I think even at this, look how simple this model is, and I've already got all of these different runs. If I didn't have these named, I actually could come down here and export the data and dig through a big long CSV and find all of my inputs, but I'd much rather know what I'm doing so that I can just look at it within the model. So anyway, I'm back to here, and this is so the 0.1, 0.2, 2.51 are, that's 0.1 U value, 0.22 solar heat gain coefficient, 0.51 visible transmittance. And what have we got here then? We have our EUI went way down, right, from 55 to 37, and our cooling load is almost gone, and we don't have any shading right now. So just showing that there's different ways. So this is the other glass that we just had. This is actually the original glass with shading. This is the 90.1 glass without any shading, and this is our new high performance glass without shading. So we're really accomplishing a lot that we were trying to do with physical shading just with the glazing design. But again, this is a pretty high performance, expensive setting or glazing package. What if we now tried to shade it? And I'm not gonna run these. I think well, remember what we could do is we could come in. I will run this one. I could go back and add in my shading that I had in my previous runs, and let's see. I'm going to add these two. Oh, okay. So I'm going to select these two. This is these two layers which have my shading on it. I'm going to select the shading button, and here are my shading objects now. If I run this with this glazing package, which remember had a very low solar heat gain coefficient, then I don't end up even doing any better. So I actually do worse. So here's the previous, here's the current. So we actually went down a little bit in our EUI, but we did lose a little bit more of our cooling load. If that was our goal, we might want to add the shading, but I'm not sure if it's enough to warrant that expense. But it's also an architectural decision, right? We're not designing right now. We're just playing around with the model to see how it works. Next, let's try a glazing package that has, I'm going to turn off this shading both here and in the model. So you do that. If I select all three of these, I can just delete them at the same time. Remember, even if that is off, if something is off in the graphics window, but it's on over here in my thermal settings, it's going to run. I can turn everything off, and I can still run this model, and it would run the same as if I had it on. So just remember that. Okay, so let's try a different glazing package now. And I'm going to, let's see, let's go to, I just noticed that I didn't actually change that glazing from before. So it's really important that because I'd already run the simulations, and so I didn't even look at the actual data. So I should have changed that to this set, and so you can always check that you've done it here. We can see what our settings are and go back and look at the glazing here. But now I'm going to change this again. So I'm going to select these three and edit the glazing. And let's pick something that has, so remember this one has a really low solar heat gain coefficient. Let's try something that's got a really high solar heat gain coefficient, still pretty decent U value, and a really good visible light transmittance. But this is probably going to bite us because we're almost doubling the U value to get this extra solar heat gain. But again, we're still, this is way better than 1, which is what we had when we had the single pane of glass. Okay, so I'm going to select that, say OK here, and no shadings on. I'm going to run it. So that result is up here. By the way, I'm going to say something right now. If you're organizing your layers like this, the default is for the date. So the time you ran your simulation to be the organizational filter. So if you ever open up your file and you see weird things like things are not in order, like I've got C, E, F, D is way up here. If you just click on the date back and forth and then hit the name, it'll reorganize these correctly. And then you can do it whatever direction you want. So now I'm on, this was the last one I ran here, but let's just look at the one that I've named so we can keep track of it. So this is the new glazing. And let's just remind ourselves. So we had the low solar heat gain coefficient glazing with, this was our cooling load, this is our heating load. We added shading. It actually got a little bit worse, but we got rid of the cooling load. I mean, our energy usage got a little bit worse. Now we tried a high solar heat gain, triple pane glass, and actually got much worse. And then if I go and add shading to this, I won't do it. Just, if we go add that same shading, I can basically get back to the same values I was at before with the unshaded low solar heat gain coefficient glass. So the point here is simply that there's a lot of tuning you can do with this, and when you get into a project you're really taking seriously, it's something you probably will want to do. Of course, this is a tiny little building. We're just playing around here. The dynamic's going to change when we get larger. So what else could we do with glazing? Well, of course, we could use less of it. So I'm going to do that. I'm going to do a run with this glazing setup. By the way, we're not going to see a huge effect because I'm already using really high efficiency glazing here, and our envelope is not that great. We haven't talked about the envelope yet. I mean, it's decent. In other words, the assembly that the windows are set in. But let's do it, and just remind ourselves how we would do that. If I come back, I'm going to have to delete these existing windows. So I can just do that. If I select, well, let's do it this way. I'm going to delete them all together. Say OK. Then I'm going to select this layer, add windows. Let's go ahead and add in the triple pane that we just were using. Let's scroll to the top. I think we'll add in the original low solar heat gain, the 2.22 that we used previously. Say OK. And now here's all those windows, right? 2 on each facade. Remember that the program knows where to put the windows and keeps track of what facade they're on. So we could go in and change the type of window that we had on the facade based on the solar facing if we wanted to. Anyway, let's run this. And our results are here. This is that run renamed. So I can keep track of it. I'm saying F2 because that's my second fenestration package, and this is the glazing that I used. We are now, let's see, if we compare it to the original, pretty much the same. We changed somewhat a little bit our heating and cooling loads, but the total output's about the same. So it's interesting that at this level, reducing the glazing is not really helping us in terms of our energy profile. But now as a final thing, let's try the high solar heat gain coefficient glass with the shading. So I'm not going to actually do it, but just so we have a visual, it's going to be this shading with the glass that had the high solar heat gain coefficient. You can look back and see what I'm talking about. And this, when I ran that, this was the result. So compared to the original low solar heat gain, we got the high solar heat gain with a little bit more higher U value, or like 30% higher U value, and shading is our best setup so far in terms of EUI, the total amount of energy we're using. We basically got rid of our cooling load, though. I think down here we got rid of it even more so. Maybe here was it? Nope, that one even had more. Anyway, we've been, we were pretty successful in getting rid of that cooling load. But mainly what we were doing here is just thinking about glazing and all the different variables that go into that we have to choose when we're choosing glazing for our projects. All right, next we will add some zones and start turning this into an actual project. Oh, but one thing I wanted to point out, if we go back and look at our original first glazing, this would maybe be like something we were having to retrofit because the glazing is probably out of date. And we look down, we've been focused just on energy and heating and cooling loads just as a way of understanding what's going on or how we're affecting performance by making changes. Let's look at our energy flows in the building here. Oops, I'm sorry. Not energy flows, zone temperature curves. We may remember back, if you look back at the other videos, when we had that initial configuration, it was a building, it has windows and an envelope. We had, and we, we set our mechanical system so it would maintain a certain comfort zone. That still doesn't always happen, because comfort is, even if the dry bulb temperature is what you've set it at, you might have you might be next to a cold window and be uncomfortable. So there's ways we can model that also. And so we saw that there was a fair amount of time when we were out of the comfort zone. Comfort zone is gray. So this and the red is the heating period or heating season basically, and the or times when we're heating, and the blue is times when we're cooling. And we see that we had a fairly large amount of time outside of that zone with just the basic setup. Let's look at what we came up with as a final, and we see that we're completely within the comfort zone. So this is another thing that's important to keep track of, and a real advantage of high performance design like we're dealing with in this thermal analysis, is that we can really control comfort and not just energy. All right, so onward to adding zones.